All right, so last lesson of Mod 5. Is that exciting to anyone? Tomorrow we'll be working on a review. Monday is what?
Test.
Your group test. We will review on Tuesday, and Wednesday is your individual test. Okay? All right, so let's refresh our memories about some things here. These polynomials are already in factored form. Do you see that? I'm not going to make you suffer through going and factoring the polynomial. We did that last chapter. Do you remember that? Mod 7. Spent a lot of time factoring polynomials. Now I'm going to show you how do you go from factored form to the graph. All right? And we're going to take the graphs that we did yesterday and make them a little bit more accurate. Because yesterday they were really just rough sketches. Okay? Yesterday they were the equivalent of stick people. Right? Now we're going to actually make our stick people a little bit more accurate. Now the only way you can get a truly accurate picture of a polynomial graph is through a graphing calculator or a computer. So we're going to do the best we can by hand. All right? So here we go. When I have a polynomial that is factored, like this, what are my two roots? X equals what? 1 and -2. Do either of those have a multiplicity that is greater than 1? Do either of them have a multiplicity? No. They're both just single roots. So I could look on my graph, and these values are my my x-intercepts. So 1, you can see that right there, and then -2 you can see right there. So when it's in factored form, it's very easy to pick out my x-intercepts. Does that make sense? Now, both of these x-intercepts are what I call a cross. They just cross the x-axis. They don't do it with any style or any flair. They just go straight across the x-axis. That's it. Then we get to something like this guy over here where my root is +1, and it's not crossing the x-axis. It is kissing the x-axis. We talked about this a little bit. Why is it different than these guys? Well, these guys had no multiplicity. This guy has a multiplicity of what? Of 2. So when you have a multiplicity of 2, you're not just crossing through the x-axis there, you are actually kissing the x-axis there. That was actually on your Mod 7 test. Do you remember that? There was one graph that had a kiss in it, and I was hoping that you would recognize that and be able to use that root twice in your synthetic division. All right? And then finally, we have something with a multiplicity of what? 3. And it's not kissing, but it's also not just going straight through. It's kind of bending a little funny. And we call that a point of inflection. So when we have a multiplicity of 3, we have a point of inflection. So not all x-intercepts are created equal. They look different based on their multiplicities. So we're going to use that information as we graph these. All right? Now, if this was yesterday, and I gave you something like that, you probably would wonder what to do. But eventually, hopefully, you would be able to figure out, okay, that has a positive leading coefficient. Right? There's my leading coefficient. That means the right side's going to go up. Correct? My degree is what? 3rd, which is odd. So that means the left side's going to go down. And with a 3rd degree, it's going to have 2 bends. So this is what you would have come up with yesterday. Something like that. Right? Yeah? We're going to take it one step more accurate. We're going to put an XY axis with it. So, let's find our roots. X equals -1, x equals +1, and x equals -2. Let's mark those x-intercepts on the x-axis. All right? 1, I only need to go to 1 on the positive side. I need to go -1 and -2 over here. So I'm going to take this graph and make it go through those points. You ready? If the right side goes up because I have a leading coefficient that's positive, the 0 or the root that's furthest to the right, I know that after that my graph is just going to be going up. If it's odd, I know that the left side is going down, so I'm going to go to the x-intercept that's furthest to the left, and I know that anything after that, it's just going down. Kind of sort of makes sense so far? Now, all of these roots, they were just single roots. None of them had a multiplicity to worry about, which means that all of them are just plain old crosses. There's no kisses and there's no inflection points. So, this is just going to cross straight through. This is going to cross straight through. And this is going to cross straight through. So I should be able to see that at some point this is going to have to curve around to meet up with that. And at some point this is going to have to curve around to meet up with that. So I took my stick people drawing, the very rough sketch, and gave it at least a little bit of accuracy with regards to width by using those intercepts. You okay with that? All right, let's do it on another one. All right, I have a root of -3 and another one of +2. This one has a multiplicity of 2. So at -3, am I going to have a kiss, a cross, or a point of inflection? At -3, it's just going to be a cross because that one has no multiplicity. At 2, I'm going to have a kiss because that one has a multiplicity of 2. Got it? So let's see. Let's put those guys on here. 1, 2, 3. There's my -3. There's my 2. I know that this one is going to be a cross, so it's going to go something like that. I should do it straight up and down because I don't know if it's going to go down or if it's going to go up from there yet. And then this one's going to be a cross, so it's either going to be like a U shape that touches there or an unhappy face that touches there. I don't know yet. My leading coefficient, is it positive or negative? Negative. What does that tell me about the right side? It's going down. So from this point, it's going to go down. That tells me that my kiss is going to be underneath, right? Because I can't go through the axis and still have a kiss. So if that's going to be underneath, doesn't it make sense that this is going to have to bend somewhere to connect? It's going to have to turn somewhere to get back there. Yeah? And I'm hoping that I have an odd degree. Do I have an odd degree? And what is it? It's a third. And that works out well because my left side is going up, opposite the other side. Now again, yesterday you would have had something like this. Today we've taken it a little more accurate there. Okay? All right, and this guy, what's my first 0 or my first root? What do I get from here? X equals 0. What do I get from here? 3. And that has a multiplicity of what? 3. Which means this intersection is going to be a cross. This one is going to be a what? A point of inflection. So let's get those points on our graph. Here's 0. Here's 3. Is my leading coefficient positive or negative? Just look at the very front. There's nothing there. It's positive. What does that mean about the right side of my graph? It's going up. All right. What's my degree? 1, 2, 3, 4. A fourth, which is what? So what does that tell me about the left side? It's also going up. Now, I'm hoping that you can see that it's going to have to come down here somewhere and then curve back up. You see that? It's going to have to go like that. Yesterday, 4th degree, you would have drawn something like this. Right? It's going to look a little different. At 0, that's the point where it's a cross, so it's just going to go straight through. Nothing fancy about it. At 3, however, that's where I have my point of inflection. So at some point, I got to turn around, and then I have to do this little wiggle thing at my intercept to show that it's a point of inflection. Looks a little different than my sketch from yesterday, doesn't it? This is more accurate. Okay, so. Now, the only way that I could get more accurate with this is if I put an XY chart and I started picking a whole lot of X values to see what it was doing at 0.01, 0.02, 0.03, 0.04, 0.05. That's why the most accurate graph you can get is easiest to do on the computer. So we're going to take this and just go one step more accurate, just one step. We're not going to do a million XY values on an XY chart. Okay? So here's what we're going to do. We're going to take this exact problem, exact same problem, we're going to take it down here and take it one step more accurate than this. The only thing on this that's not accurate currently is how high or how low that goes. I don't know that yet, right? By the way, let me mention something about your homework. Hang on, that's not tonight's homework. Got put in the wrong pile there. Okay. On tonight's homework, you're going to know how, and on the test, you're going to know how accurate I want your graph based on what I give you. If I don't give you any axes or anything, this is as accurate as your graph needs to be. If I give you just an X and Y axis, this is how accurate your graph needs to be. If I give you a full-blown grid, that's when I want you to do the XY table that I'm going to show you now. Now, on your homework, it wasn't quite that easy, but I want you to do a graph for numbers 1 and 2, and also on the back side 7 and 8. I want you to do a graph like this. So I do want you to do the XY axes, and I want you to put values on your x-axis, but you don't need to put values on your y-axis. Okay? So on your homework, that's the accuracy I'm looking for, just to make sure that that's clear. Okay, so we found that we had zeros at -1, 1, and -2. Yes? So -1, 1, and -2. And I know that because it's an odd degree with a leading coefficient that's positive, the right side's going up and the left side's going down. Yes? And I know that in the middle, it's going to go up and curve back down and go down and curve back up. But I don't know how high it's going to go here or how low it's going to go there. How could I find out? I'm going to use my XY chart and just look at points between my zeros. So if I want to know how high it's going to go before it comes back down to this 0, let's pick a number between these two zeros and see how high it is. So what would be a good number between these two zeros? -1.5? Yeah? What about between these two zeros? Between -1 and 1? 0. Those are the only two values I really need in my XY chart. I don't need to do a full 5 points or anything like that. I just want to see what's going on between the zeros. So I'm going to take -1.5 and I'm going to plug it into this equation. 4 parentheses, -1.5 plus 1, parentheses, -1.5 minus 1, parentheses, -1.5 plus 2, and I get 2.5. So if -1.5, 2.5 is on my graph, that gives me a better idea of exactly how high that goes. Does that make sense? And if I go back and I plug in 0, I have 4 times 0 plus 1 is 1, 0 minus 1 is -1, and 0 plus 2 is 2. I get negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I now have an idea that this actually goes all the way down to here before it's going to curve back up. So again, least accurate, little more accurate, lot more accurate. The only next place to go from here would be to the computer. Okay? Now, just out of curiosity to get you thinking a little bit, do I know that this is the lowest place that this is going to go? I mean, I know that I have domain and range are both all real numbers, correct? Because I have a third degree and because my ends are going like that. But do I know that this is actually the minimum value of that part? Not exactly. The only way I could find out would be on a computer, because maybe the minimum, maybe it actually goes to -9 before it gets to -8. I don't know. But at least I have a better idea than I did up here. All right. All right, so let's talk end behavior. X arrow infinity. What side of the graph is that talking about? The right side. What's going on the right side? It's going up towards positive infinity. And X arrow negative infinity, what part of the graph is that talking about? The left side, and that is going towards negative infinity. So not too bad, right? Taking what you've learned and adding 2 points on an XY table. All right, let's go to this guy. This is the exact same as our 4th degree that we did up here. So we're taking this guy and taking him to his next step of accuracy. So I have a root or a 0 at x equals 0. And I have an inflection at x equals 3. Yes? I know that both ends go up because I have a even with a positive leading coefficient. Yes? All right, so if I want to know what's going on between these 2 points, what should I put in my XY table? Do I want to do 1.5 or do I want to just do 1 and 2? Do grid lines whenever you can. Even if it means doing 2 points, do grid lines. Doesn't take long to plug it in. 1 times 1 minus 3 to the third is -8. And if I go change those 1s to 2s, I get -2. Takes me 10 seconds to do that. All right, 1 -8 is down there, and 2 -2. Now, why isn't this one nicely going like symmetrically back up? In other words, why? I would think that the lowest point would be halfway between those 2 zeros, but it's not. Because it's got to start coming up here. And the reason has to do with the fact that you've got your inflection point right there. So you have to make sure you have that little wiggle that goes through there. Kind of sort of makes sense? So again, very rough sketch. A little bit closer to the real thing. A lot closer to the real thing. What's my domain here? All real numbers. What's my estimated range? Y is greater than or equal to what? -8. And my end behavior, x arrow infinity, that's asking about the right side. It's going up. X arrow negative infinity, that's asking about the left side, and it is also going up. Questions? All right, here comes your homework. Happy studying.